In episode 1, I presented to you the official unit of length that I would be using for the game, and even some formulas for conversion. However, these formulas do have a bit of a problem. Let's fix that. Hello, Count Sacke here, back with another GD Dynamics video. In this episode, we'll be adjusting the formulas that I presented back in episode 1, and if you haven't seen it, you'll need to watch episode 1 obviously in order for this episode to make any sense. Alright now, so let's get into it. So to get things started, I want to establish that no, these equations aren't wrong. In fact, they work fine. But there is one serious problem about them, and I even mentioned it in the first episode, so let me play a clip here. If we were to zoom in or out while in the editor, the amount of pixels for a single object would change, meaning that pixel measurements become obsolete, but not hopeless. Instead, we need to consider a ratio. Yes, these equations only work in the case where one block is exactly 122 pixels. However, that would be very unlikely and pretty annoying to properly measure things. So in this video, I want to derive a new formula so that we can take into account any scale, hence relative scale. For a start, we already have a formula, but I said this is only for a special case. L is equal to 1b divided by 120p multiplied by m. The problem is that m needs to be in the scale where 1b is to 120p is true, so let's take a ratio of m is to 120p. Well, the best way to convert things is through ratios, so therefore let's equate m is to 120p to another ratio, but this new ratio will consider your relative scale. Let d equal the distance you measure in your relative scale, and let beta equal the length of one block in pixels to your relative scale. So now we have the ratio d is to beta. We can take these two and equate them to each other because 122p and beta are both the length of one block, and m and d are the same length but in different scales. We can isolate m very simply by multiplying 122p to both sides, and we are left with this equation. M is equal to 122p multiplied by d divided by beta. Finally, we can substitute this back into our original equation, and we're done. The formula that we have is L is equal to d times 1b divided by beta. So in this formula, beta is the length of one block in your scale, and d is a distance in pixels relative to the beta scale. 1b is just to convert the values to block, and L is the length of d converted to blocks. The reason this formula is more important than the original is because we can now account for any possible of scale in GD. No matter how much you zoom in or out, this formula will work. The only requirement is that when you measure d or b, you cannot change the scale. So I was actually originally going to end the video right here, but then I decided that I didn't actually show you guys how to use this formula. And well, I'll just demonstrate right here. So currently I just have a scene with, as you can see, we have the default block, which is what which is going to be used for our value of beta. And we just have some lines that we are going to be using to measure. And here we'll have a special case, which is a Pythagorean theorem. Now, the first thing to do is that I should note that technically, when you're zoomed in closer, it is more likely that you're probably going to have a more accurate count for this distance. So the best idea is to zoom in as close as you can while keeping the default block in the same picture. So what we're going to do here is actually, I'm going to take a screenshot. So I'll just take a screenshot here, and I'm also going to move this guy over here. So pressing D, I'm gonna move. Come on, we don't actually want to obstruct it. So we're gonna take another screenshot here. And lastly, we're going to do the same thing, but for this one. All right. So the next thing is what I'm going to do is I'm going to go over to GIMP. So here we actually have our current state or what we currently have. We don't need to work with that, so we can just go over here and focus on this. Now, there are many ways that we can actually do this. I just basically, for me, all I really need to do is in GIMP. First off, we basically just need a count for beta. Beta is equal to, well, if we zoom in here, we have to measure the size of this block. As you can see, we currently have a value for the size, which is 202 pixels. So with that, we can say that this is 202 pixels. And now for our distance we have is d is equal to, well, we have to measure the length of the line. So now we're going to go here and, well, do the same thing, measure this length of the line, and keep in mind that this is the horizontal, so we're going to be taking this, which is 810. So this should actually approximately be 4 blocks. However, obviously I don't believe it will be perfect. So I'm just going to very quickly set up a Desmos for this thing. So over here, if we input our value, so beta is 202 pixels, and our distance is 108. And well, oh, we can't. Okay, we can't use it. Never mind. So let me fix that for a second. So basically, our length is, yeah, it's basically four blocks, and well. And we know it actually is 4 blocks because, well, this is exactly 1 unit, so this is exactly 4 blocks long. However, it's just because we have a bit of a margin of error when measuring things, which is unfortunate, but we can't really do anything about it. So next I'm going to bring the next one, which is this one. And once again, we don't need to look at any of these. So I'm going to just crop out I'm only going to focus on the important stuff. So let's go ahead and just measure the size of this guy. And there we go. So now we actually have a very interesting size. And yes, you will encounter this. We have a size of the block where it's not exactly perfect. And well, I just think it's best to, since we're measuring along the horizontal, and we know that this first number is the horizontal, is for the horizontal, yeah. We basically have that as our beta. So this is 203. And well, our distance, if we look at it, it's approximately maybe a little bit less than 2.5. That's our guess. So right now it's 500. That looks okay. Yeah, it is 500. So then our distance is 500. So it should be about 2.5. I would expect it to be a little bit less. So if we input our values, so it's this, and this is 500. Yes, as you can see, this value makes sense. It's about 2.5. Here we have to use the Pythagorean theorem. Once again, we have to do the ritual of measuring it in measuring the basis block. So, and well, we're lucky this time. We actually have the same value, so we can still use this. However, now we're going to have to do something different here. Because we're trying to measure this slope, well, we have to use Pythagorean theorem. So first we need to measure this horizontal component and the vertical component. Luckily for us, the horizontal and the vertical components of the block are actually the same. So we're actually going to have to modify our function here. So, well, d sub x is going to be the horizontal, so let's measure that. And there we go, we have our 405. So 405 for the x. Now for the y, we're going to have to measure that from here and all the way up to, well, I'm going to still say like here. This is 202. So with that, we can say that this is about 2.2, yeah, 29. And if you think about it, if you were to turn the plane a bit sideways, and well, you can kind of say, yeah, it is about 2.2 long, this slope. So yeah, that's really how you're supposed to use it. And one thing to keep in note, you cannot, if you really just can't get the basis block and the line that you're trying to measure in the same spot, what you basically have to do is, if let's say, for example, that you have the block and it's all the way over here, and for some odd reason you can't take a picture of the two together. So what I would recommend is that, one, you make sure that you're in the same length. So let's say that this is the scale in the same scale. So let's just say that this is the scale that you basically you have to work with. So what you have to do is you take a picture of this basis block, then you're going to have to move over to the line that you're trying to measure without changing scale. I kind of messed up because I changed scale. So once again, I would have to go back over here, take a picture, and then do the same thing, but over here. But I would like to say that this still may cause a more larger error because when you move around the camera, the pixels are also shifting. And as we saw with one of the pictures, there appears to be times where things aren't exactly perfect. So if I can recall right here, this is not a perfect square. Yes, as you can see. So yeah, just keep that in mind that it's best to keep the lines within the same picture and the things that you're trying to measure in the same picture. And with that, I'm going to end it here. So yeah, I'll get into that final clip. So that's really about it for now. So thanks for watching and hope you enjoyed.